Okay, part 2 of our practice SAC questions. So we're going to look at this problem. We have the acceleration of a particle at time t is greater than 0, is given by this function. It's a sine function. Now the velocity of the particle when t is equal to pi is this vector. We have to work out what is the initial velocity of the particle. So first off, what we can identify, we have the velocity as a vector can be determined as the integral of the acceleration vector. Okay, so that's the first idea, is using calculus to form that connection. And when we carry out that integration, we are going to end up with integration constants. Okay, we also have to consider that when we integrate, we're not just integrating in the I component, we're also integrating in the J component. Now, currently, our J component here is not written, so you have to think of it as a 0 in the J. Okay, so when you integrate a 0, you get a constant, so that's why we've introduced a d integration constant there. Okay, so now we go ahead and sub in t equals pi, and upon substituting, we have that equal to the velocity of the particle that's stated in the question, 2i plus 2j. Okay, and then simplifying, okay, cos of pi is -1, so we get a positive 2 plus c, I plus d in the j is equal to 2i plus 2j, and from that we can work out that c must equal to 0 and d must equal to 2. And so now we want to work out what's the initial velocity. The initial velocity occurs when v is equal to 0. When t is equal to 0, so what is that velocity? So substitute t is 0 into our velocity vector and simplify it, and we get -2i plus 2j, which is answer C. Okay? Okay, let's continue. So, next question. First off, we have our golf ball is hit from an origin at ground level. At time t, the velocity vector of the ball is given by this velocity vector, where I is a unit vector in the horizontal forward direction, so that's going from left to right horizontally, and j is a unit vector in the upward vertical direction. So j is looking at the motion of the ball off the ground, going up into the air. So the position vector of the golf ball at its maximum height is given by what? Okay, think about which part of the vector is responsible for height off the air. Is it the I component or the J component? Okay, so vertical direction is your J component there. So the max height occurs when the velocity is 0, only in the J direction only. Okay, so if you examine that, we'll take the J component, 18 minus 6t is equal to 0, and we can work out that t must be 3 seconds. Okay, so it's the first thing done. Next, we are going to work out what is the position vector. Okay, now the position vector is going to give us our maximum height. Alright, so we integrate the velocity vector to work out the position vector. Okay, and we achieve this. Remember to use the integration constants when you integrate. We're going to have two different integration constants, the c in the I direction, and when we integrate the j function, we're going to have a d. Okay, and then from that, we're interested now to work out what c and d is, and because the ball was hit from the origin. Then at the origin at t equals 0, we've got 0i plus 0j. Now that is important to recognize. Whenever you refer to the origin, then those are the values of the vector for I and j. Now from that, we can work out that c must be 0 and d must be 0 when we substitute t as 0 into the above position vector function. Okay. Now, what is going to be the position at the maximum height? Well, the maximum height occurs when t equals 3 seconds. So we substitute 3 into the position vector and we evaluate. And we get 36i plus 27j. Whoop. Let's back it up a little. Okay, now we can see from that has to be answer number B. Okay, I hope that is helpful. Let's try the next one. So, question 7, the position of a particle at time t seconds is given by this position vector function, and the speed of the particle after 4 seconds we have to find correct to the nearest tenth of a second. Okay, so first off, what do we know about speed of a particle? Let's get that definition down. Speed of a particle is the magnitude of r dot, which is magnitude of the velocity vector. So let's go ahead and work out what is the velocity vector, r dot. We're going to differentiate. So differentiate t squared minus 3 and we get 2t. Now we're going to differentiate our square root function. You can do that on the CAS, or recognize that you take the derivative of the inside function, gives you 6t, that comes out the front, and then we differentiate a square root. Now it becomes to have negative a half with the function on the inside, and we've just got the power that comes out the front, the half. Now, just simplifying that, there's your vector function for velocity. Okay, so once you've got your velocity function, we're going to find the magnitude. Magnitude is given by that, the square of each component added together and then square root. You simplify that, and we have that as our speed function. Okay, once you get your speed function, we're interested to know, well, what is the speed at 4 seconds? So at 4 seconds, we're going to substitute it in and evaluate. We get 8.2. Alright, let's move straight into it. Question 8. The motion of a particle is given by this acceleration time graph below, where time t is in seconds and the acceleration particle is in a meters per second. Okay, so here's a motion graph. Now, normally we're used to working with a velocity time graph. This is an acceleration time graph. Now, from that, it says in the question, if the initial velocity of the particle is 24 meters per second, the distance traveled by the particle in the first 6 seconds is equal to. So we have to work out distance from starting with an acceleration time graph. Now, that doesn't seem to be straightforward, because normally we could get distance or displacement from a velocity time graph, being the area under the curve. Okay? So if you look at an acceleration time graph, the area under this curve would give you velocity, not distance or displacement. So can't really approach it by examining area under this straight line curve here. It's not going to get us close to distance. So we got to think about it another way. First off, reading from the graph, we notice, okay, straight line. So if I work out the equation of this straight line, I have a function for acceleration in terms of time. So let's aim for that. Rise over run gives you -6. You can examine that by seeing how many units in rise divide how many units in run, and then we're going to use this formula. This is the formula for working out the equation of a straight line. Substitute m equals -6 and taking a point such as, this point here. When x is 4, you have y equals 0. Okay, so where do we get up to? We're finding the equation of the straight line to know some relationship between acceleration and time. And so in terms of a and t, acceleration, we've got acceleration equals -6t plus 2. Now, from that, we have to work out what is going to be the position, or and then we can get the distance traveled. Okay, so we have to use calculus. We have to integrate twice. First, we can integrate to get the velocity. Okay, and so we get a quadratic from a linear function. Now, we're told in the information coming down here at the bottom part of the graph in the question, if the initial velocity of the particle is 24 meters per second, that means when t is equal to 0, we have v equals 24, and we use that to work out what is c, and we get c is 0. So put that together, we get our velocity function. Now when we integrate again, we're going to get the position, the displacement, but the distance traveled is going to be the displacement from the origin, okay, from 0, and up to t equals 6. So the distance traveled in the first 6 seconds, you can work that out by doing a definite integral with limits from 0 to 6 and integrate velocity to get your distance traveled there. Okay, and what we had there was the 360 meters as your answer. Slow down. Alright, sorry. Let's continue. So here's that was the end of our multiple choice questions. If there's any other part that we're unsure about, we can send me a message regarding the multiple choice questions and we can go over them again. Let's look at question 1 of our short answer in this video. Okay, so question 1, we've got a position vector of a moving particle. It's given by this position vector function. Now, our job is to find the Cartesian equation. So first off, we relate the x function is given by the I component. There it is. So x equals 4 cosec squared. Alright, looking at your I. And we do the same for y. Y is 2 cot. Okay? Now, using those two, we have to combine them somehow to via a trig identity and put them together to form a Cartesian equation. So first off, rearrange them, okay, to get just the cosec function by itself. Same with cot function, and then square it, because cosec squared and cot squared relate to each other via this trig identity. Okay, 1 plus cot squared is equal to cosec squared. So using that trig identity, we're going to form this Cartesian equation by doing the substitution. Okay, and now we can rearrange for y, and we get that. Now, that's not the answer, because first off, there are two possibilities there, the positive square root and the negative square root. Okay, we have to make a decision on which one it's going to be. Is it the positive square root, is it the negative square root, or is it in fact both? So now we must examine the domain. Okay, so first off, we consider this. The domain of the Cartesian equation is given by the range of our x values. Okay, so using the domain for t, we're going to work out what are the corresponding x values to work out the range. So pi on 6, we get x equals, we substitute that in to our x function, we get 16. Okay, but when t is pi on 4, x is going to be 8. So we can see the x values range from 8 to 16. Okay, so there's your domain for the Cartesian equation. Okay, now don't just stop there, because what we also are interested in are the range of values for your Cartesian equation. Now that's going to give us an indication on which of the two rules here, the positive or the negative, is the correct one. So the range of the y function with respect to t is the range of the Cartesian equation. So again, we do the substitution, this time into the y function. Okay, first one gives you 2 root 3, and when t is pi on 4, we get y equals 2, and we note that, hang on, they're all positive. Okay, they're all positive. So there's no negative values, and therefore only the positive square root is the correct one. And when you state the equation, you must also state the domain next to it, because this is a restricted function across this domain. Okay, so there's the correct Cartesian equation for this vector position function. Okay, that will give you 2 marks generally, stating the equation plus the domain. Alright, well, that's it for this video now. I'll have part 3 available for your weekend, and that will look at the remaining questions of our practice SAC. Then I'd like you to complete the Google form to identify which is your best questions. I have a multiple choice and short answer questions, and I will collate all the responses, and perhaps those best questions may reappear in the actual SAC in some form. So look forward to that. Thank you very much.